Here in our final module, we're going to be looking at proteins, which are kind of like the fancy biomolecule. They're in charge for this huge array of structural and therefore functional diversity. And we're going to see what it is about the structure of proteins that makes for this structural and functional diversity, as well as how proteins are made at the very end, the basis of how they're created from nucleic acids, DNA, very broadly. So protein structure, we're going to revisit enzymes, which are a big, part of protein's role in the body is being enzymes really. And we're going to take a look starting here. We're going to start with kind of a broad look at proteins, specifically, proteins' big picture role in the body. And also what proteins look like. We'll often see proteins shown in the image on the right here, where we have these ribbons and we have these straighter areas, because proteins are really large molecules and we don't always want to see the atomic level structure that we want to see in some other forms of matter, right? When we looked at lipids and we looked at carbohydrates, that didn't get in the way as much. But here, we could have molecular weights of 10,000, right? That's a bit too large to show effectively if we're showing every single atom. And furthermore, protein is really known as, a meat-based type of food source, right? We talk about, protein and eating protein and it's healthy and all that, right? So what is it about meat that makes it such a good source of protein? We'll talk about that as well. But to begin with, let's start with amino acids. Proteins are polymers, and we've seen this theme over and over again, right? We've seen it in carbohydrates, where we have the glucose monomer that adds to make bigger carbohydrates. I should say, glucose and other carbohydrate monomers. But we have monomer units that make large complex molecules, and proteins are no different. This is an amino acid, and we can see it because on the one side, on the left here, we have an amino group, and this is nitrogen, right? Amine means nitrogen. And on the right, we have a carboxylic acid. We've seen this before. This is that COOH group. And so it really is an amino acid. Amino on one side, acid on the other. And they differ by the presence of an R group, which is a to be determined molecular structure. We'll see that in the following page. That's attached to this carbon that bridges between the amino and the carboxyl groups. This is the carbon in the middle. 20 standard amino acids, and these amino acids link together in long chains and fold into really specific three-dimensional shapes. And it's the structure of these amino acids that are the beginnings of why they have such complex functions and structures. And so here are the different R groups, right? And so this is by no means something that you need to memorize, but it is here to show the diversity in the different R groups, as well as how we can classify them, right? Are they polar? Are they non-polar? Are they charged? This will determine protein structure in the incoming, depending on how the amino acids are added together. And so with this in mind, right, just kind of practically speaking, if we have a protein that's made up of mostly amino acids with non-polar R groups, what properties do you think that protein might have? Go ahead and pause here for a second and see if you can answer. All right, if we have mostly non-polar R groups, what properties are we going to have? Well, it's going to be hydrophobic, lipophilic, right? If it's mostly non-polar, then it will be a nonpolar molecule. And so this is a good broad distinction for our protein or our polypeptide, right? Multiple, amino acids linked together. The properties of the R group will lead to the properties of the overall protein. And, amino acids, right? There are 20 of them. From a dietary standpoint, we can separate these into essential and non-essential amino acids. And we call them essential because they're essential for our diet. We can't create them. We have to harvest them from food. The non-essential ones we can piece together from, other things that we eat, right? We don't have to eat the amino acid itself. But the essential amino acids we do. They have to be harvested from food. These are building blocks for future proteins that we're going to create. And our body is always creating proteins. When we're dealing with amino acids, they have a 3-letter code, which is pretty descriptive of the name of the amino acid itself. But they also have a one-letter code, and so that can be shown, but isn't quite as descriptive, right? There's only 26 letters, so they're not always as easy to intuit from the amino acid name, but these are widely used three-letter and one-letter codes. Finally, when we talk about essential amino acids, we can talk about a complete protein source, which is one that contains all amino acids, all essential amino acids. And meats and animal sources are rich in protein. These are always complete sources on their own. And while a plant-based diet may have challenges finding really easy, complete sources of protein, they are out there, right? They're not that hard to get. Most of the plant-based high protein sources that we would think of may be missing one or two essential amino acids, but it's not like there's only one available and you have to piece together 7 different things. And so here's some examples of some common meals or snacks that do pair 2 plant-based sources into a complete protein. And I think this is a really good list for, if you're in healthcare and thinking about patients that you might have who may want to be vegetarian or who may not have like the greatest financial resource to get food. How can we get complete protein sources that will, be conducive to good health, right? Eating just one thing all the time can lead to deficiencies. Eating things like this are helpful, right? And there are a few here that are just plant-based, complete proteins on their own. But that said, a lot of times we pair beans and rice or beans and grain, and it easily makes a whole protein. Getting good protein when you're eating a plant-based diet is not impossible, and here are some great places to start.